Right, so today we are going to discuss one of the applications of cross product. And now let's have a look. So let's suppose I have 3 points on the XY plane. For example, the first one is A, and that's located at 1, 1. And then this is the second one, B, at 4, 2. And we have another one, C. Yeah, and that's at 5. That's at 2, 5. Now, as you know, when we have 3 points like this, you can create a triangle. Basically, you can create a triangle. And then the question is, find the area of the triangle. Now, normally, if you have learned geometry, what you do will just be, sometimes you need to remember some of the formulas. So in this case, you need to get the distance between 2 points. For example, the distance between A and C. So we know there is a formula like this, that the distance between 2 points is equal to square root of the xc minus xa square, and then plus yc minus ya square. And then after you get that distance, you get the other distances, from A to B and then from B to C. And then after that, if you remember, there is a formula to find the distance when you have formula to find the area when you have this length of the sides. Yeah, that's fine. I mean, normally if you know some of the geometry formula, they will be great. But probably these processes will be quite lengthy, Now, what I want to show you is how can we use the knowledge of vector to get the area of the triangle. Now, what happens is when you have 3 points like this, you can create 2 vectors. You can create 2 vectors. So that's the first one. And also I have another one from A to B. So we have now vector AB and AC. So these are the vectors coming from one point to another point. For example, AB, it's the location of B minus A. So in this case, 4, 2 minus 1, 1. So we get 3, 1. And if we have a vector from A to C, that's simply C minus A. So that's 2, 5. And then minus 1, 1. So that's 1, 4. Now, as you know, when you have 2 vectors like this, they make a parallelogram. So this is the two-dimensional shape made of 2 vectors. Now, I know when we want to get the area of parallelogram, normally you can just do, the base times the height. But you can only do that if the sides here, they are, for example, we have the base, and then you can also calculate the height. So in that case, you can use that formula. But if the points here, A, B, C, they are quite random on the 2-dimensional space, we need to have something more general. So now, actually, we can use a bit simple situation than this one, yeah, where, for example, one of the side is horizontal, so you can get the other side and you can see the height. But in this case, I just want to show you how we calculate now the area of the parallelogram. So in this case, we can now create a matrix. No, actually, I want to do something different first. So in this case, let's now do a cross product between AB and AC. Yeah, so in this case, you will now get the matrix where the first row is the unit vectors I, j, k, and then the second row is the first vector. In this case, if you have only a vector in two-dimensional space, now you can just put the z component here equal to 0. Now this is the second vector. And then what I'm going to do is to copy the first two columns. And then after that, calculate the diagonal like this. So in this case, we have 0 plus 0 plus 12k. And then we also have another diagonal. So in that case, we have minus 1k and then minus 0 minus 0. So in this case, we have 12k minus 1k. So that's 11k. But as you know, when you do a cross product, what we get here is a vector. See, we have a unit vector here. That's why this is a vector. So what is the area now? What is the area of the parallelogram made of made of those vectors? So that's simply the area. It's given by this nice formula, which is the magnitude of that vector, the magnitude of the cross product that you got here. So in this case, the magnitude of 11k. So I know in this case, we only have one component. So it's just square root 11 square. So that's 11. So that's actually the area of this parallelogram. And as you see here, the triangle is just half of the parallelogram, right? The area of the triangle, therefore, it's just half times 11. So the area of the triangle ABC will just be half times 11, which is 5.5. 5.5. Okay, so that's actually how we calculate the area of parallelogram, and then we calculate the area of triangle using vectors. Now what I want to show you after this is actually how we can also calculate the area of that parallelogram, but rather than using cross product, actually we can do also, you know, another method. So in this case, what I'm going to do is, instead of doing cross product, I will now create a matrix. So this matrix is actually made of those vectors. So what I'm going to do is I will put those in a matrix where the first column is the first vector, and then the second column is the second vector. Now, in this case, we have something called 2 by 2 matrix. Why it's called 2 by 2? Because it has 2 rows and 2 columns. So that's how you write down the size of a matrix. How many rows times how many columns? In this case, we have 2 rows times 2 columns. So if you have the same number of row and the same number of column like this, what we have is a square matrix. Now, this is something interesting. You know, when we have a square matrix, we can calculate a value from it. It's called the determinant. The determinant. Now, what is the determinant of a square matrix? Let's start with the simple matrix A, which is, it is also square matrix, and it has 4 elements, A, B, C, D. So the determinant of A is given by this simple formula, which is A times D, and then minus C times B. So that's how you calculate the determinant of a 2 by 2 matrix. So in this case, the determinant of M, it's simply 3 times 4 minus 1 times 1. And now you remember what we just got previously, where when we calculate the area of parallelogram, we got also that number, which is 11. So this is actually another way to calculate the area of parallelogram. In this case, if you have some points on the XY plane, you can get some vectors from them and then put them in a matrix like this, and then to calculate the determinant. Now, this is actually quite general method, and later we will use the idea when you have, for example, bigger situation. Yeah, we can also calculate the area of the parallelogram later. Okay, so I think that's for today. That's for today. Thank you.